All right, everyone, welcome back to Lecture 3, Data Exploration in Data Transformation and Exploration. And so we're going to talk about exploratory data analysis, and that's visually exploring your data, and it's often called this exploratory data analysis, or EDA. And the purpose of this is to help you figure out what's going on with your data. It gives you a clearer picture of if your data entry and analyses are correct. It allows you to feel confident with your analyses. And there's really no formal process for EDA. It's simply whatever you like to do to examine your data and feel comfortable with it. So back to our pipeline, we're into the visualization part. So we're going to be doing a lot of stuff with ggplot. So let's do some EDA on our BATS data. So again, just a reminder of what the data look like. So one thing you can do is create summary tables of your data. So here, if you just write summary of BATS, you get a summary of all the ranges of your data, all your variables. And so a helpful thing to do is plot box plots to sort of look at how your data fall out. So here's an example of how to use ggplot. I'm not going to go over too much about what each thing means in the future. I'll just say for this first one that you start there's many ways to code this. The way I like to do it is to start with the ggplot statement where you define your data, and then here we're going to be calling it a geom_box_plot, right? We're going to use that function to create the box plots, and then your AES statement is where you define your X and your Y variables. The theme black and white makes it black and white, and then you can change the size of your text. I wanted you all to be able to read it, so I made it larger. And to keep your code clean, I would highly recommend having each of your geom statements for your plots on a different line like I have here. So the plus is on the previous line, and then the function is on its own line, and that really keeps it much cleaner. So here you can see we're looking at the mass of the distribution of the data for the mass of the bats for females and males, and you see that females tend to have their mass has a larger their distribution has a larger median. And say you want to look at multiple things, a variable with multiple categories, you can, and if a normal box plot is potentially too wide and you want to flip it, you can use this function called chord flip. So here we're looking at the right forearm length with each bat's condition. But say you don't like the way that those factors are ordered. So for some reason to you, the order, having the condition be in the order L, P, PL, TD, NR is better for your data. You can easily reorder it with this code here. And I use this quite a bit, especially if you're working with any sort of categorical treatment variables or anything like that. This can be really useful. And if you have two continuous variables that you want to examine, you may want to do scatter plots. So here you would do geom_point. So again, just some basic code. There's lots of things you can Google for this, and I've included some helpful links in the beginning of the slides. And if you want to color your points by the sex of the bats, you add that statement into your AES statement in the geom_point. So you just say you want to have your color represent the sex. And here you have female bats in pink and male bats in blue. That was just the standard. I didn't choose that. And you can also change the size of your points, by the way, with the size outside of the AES statement. And there's so many ways you can modify these. So here you can have your color of your points refers to the sex of the bats, but then the shape could be the age. So remember we had adults and juveniles. So here adults are circles and juveniles are triangles, and then any of the pink dots are females and any of the blue dots are males. So here you can see, you can just make it more and more intricate. And so there's lots of different point shapes that you can use. So if you're interested in trying to come up with any other sorts of shapes, here you go. Here's a list. And so maybe having, two colors and two shapes is just too confusing on one plot. You may want to separate them out. So you can use facets to separate out your data into different blocks. And so here we're still looking at the relationship between body mass and the right forearm length, but now we have a facet for each condition. And you can specify if you want this to be in 2 rows, 5 rows, 3 rows. You do that in facet wrap. And if you want to look at, in your scatter plots, if you want to look at trends in your data, you can add a line through the data with geom smooth. Here I've used the method LM and the standard errors, which is the gray behind it, but you can take all that out and the lines will be a little bit squigglier and sort of represent the actual data, not a mean trend, a linear mean trend. And you may also want to look at the distributions of your data. This can really help you figure out if your data is normal, if you've got data that's maybe more Poisson, etc., if you have some extreme outliers that you need to consider. Not necessarily that you should remove them, just how to consider them. And so here you can do this with a histogram. You can change your bin width. I've used 0.5 because the mass can be quite small in small increments, but you can change that with these functions here. geom_freq_poly is the same as geom_histogram, but instead of displaying as bars, it displays your data as a line. So sometimes this can be useful if you have a lot of overlapping categories. So I wanted to point this out. So say you wanted to look at the males and female bats separately. Here we have that in the AES statement as color equals sex. And so here you can see the lines from the freq_poly really overlap, and that can be really useful to look at. Just, if you have a lot of categories, it can be easier to see when you use this freq_poly. But again, it's still based on counts. You can also use geom density, and instead of using counts, this normalizes your data. So say you have one treatment that's really has a lot of counts and one treatment that has less, but you want to be able to compare them more easily, you may want to use a density plot because it normalizes. And so this is how you would do this, having multiple colors. Here I've used the fill for this as the sex, and then change the alpha to 0.05 or 0.5, and that allows it to be transparent.